haven't. So that's one practical application of this as well. Now there's another way to calculate the cyclomatic complexity above and beyond just that counting it up thing. And the counting will work fine if you're looking at a single function or something, but obviously if you're dealing with a file that's full of a bunch of class definitions or functions or something like that, it's going to be kind of tedious to count them. There are some tools that will help you with this. So for example, there's out on sourceforge.net, there is a free tool that will do cyclomatic complexity calculations for the Java. And I wouldn't be surprised if there's a C++ one floating around out somewhere too. So that's an option. Now there's also McCabe's Battle Map tool, which I believe is still sold. That is a somewhat bigger ticket item than a free download off of SourceForge, to say the least. Okay, so far we've been looking at control flows, so let's move on to look at data flows briefly. So what we can do to look at data flows is to use something that's called set use pair coverage. So basically what you're doing is you're looking at when a variable is assigned a value and when that value is subsequently used prior to that variable being assigned again. In other words, the value being overwritten. So what you're doing is you're watching a value flow through a sequence of variables with set use pair testing. So to go back to this Fibonacci program here, to analyze the set use pairs, what you would do is you would identify the different variables. In this case, so you've got the variables here. Let's see those guys there, I, N, P, 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 and C. And then what you have to do is you have to look at the lines where the variable is set and then where it's subsequently used. And so, for example, let's take a look at N here. We got N, we've got a set of N on 5, and then a use of N on 6. And N is only set at line 5 or line 8, right? So we set it here, and then we use it in 6. We could set it here, and if it's greater than or equal to 0, then it would be used here in the comparison. And then it would also subsequently be used here. Now, if it's less than 0, it's set and then used here, and then it's set again here and then used down here. So that's the 8 and 21. So we can then look at the values required to force the code to flow through those particular sequences that we've identified. And if we look at the values that we came up with for basis test coverage, then we can say, okay, well, what if we test with n equals 0, n equal 1, and n equal minus 1? And what you see is that you're not necessarily going to get all of the data flow coverage that you might want to get out of this set of values, because take a look at the situation where C is going to flow into P here, right? The value in C flows into P, and then value P flows into PP, and then it flows back into C here. So there are interesting data flows that can occur that are not necessarily going to be addressed by control flow coverage. So that's not necessarily a heartening thing to know, because I have not seen, and I'd be interested during the Q&A session if anybody has, I can certainly mention it. I have not seen any tool support for data flow coverage, at least not commonly out there. So without a tool to do that, obviously that would be tedious in the extreme. Now, Brian Merrick, in his book, The Craft of Software Testing, took a very different perspective on white box testing. And it's always good to come at the testing problem from a number of different perspectives. And so what Merrick did is he created what he called a catalog of test requirements based on his experience with things that tend to be buggy. All right? So this is kind of the original bug taxonomy-based approach to testing. It's probably the first documented instance that I can find of that. In this case, it's kind of refined because the bug taxonomy is generalized. So you're not looking for specific bugs, but you're looking for types of bugs, and it's generalized into test requirements. And in fact, this is an interesting parallel. If you read Merrick's book and then pick up, say, James Whitaker's book, How to Break Software, or some of the subsequent books that Whitaker wrote on the same How to Break Software Security and so forth, that series, you'll see that Whitaker's concept in many ways descends from Merrick's and is just a somewhat more formalized version of it, in the sense that there is a fundamental model underlying Whitaker's work of how bugs happen. But the idea that we can generalize from frequently observed bugs into things that we should test, and then we can cover those requirements, test requirements, with tests, then that's definitely very similar to Whitaker's idea. Now let me, before we look at the Fibonacci, let me go ahead and show you Whitaker's, Merrick's catalog. This is the test requirements catalog from Brian Merrick, and it is available out on his website. Not sure he sold that. It was on testing.com. It's somewhere else now. But if you were to take a look on the internet, Merrick's test requirements catalog, I'm pretty sure that you would find it, and you'd be able to see this thing. It's basically, there's a bunch of data-centric test types, as you can see here, simple data types, collections of data, pairs of data, and then it's got operations that apply to the data types. That's part 2, searching, streaming over sequences, changing contents of a collection. And so he then goes into a description of this, and we'll look at one example here. So for example, for a Boolean, you need to make sure that you've tested both the true and the false value, and if it's restricted to be 0 and 1 only, try to force it to be something else, in other words. And then different possible values that a variable can take on, and so forth. So this is a useful alternative way of looking at white box testing, is based on, as I said, where you're likely to find bugs. Let's go back to the presentation here for a moment. Now, what we're going to do is take a look at the application of Merrick's catalog to the Fibonacci program that we've been looking at here. So bear with me while I've got to switch applications. What I've got here is I've got the requirements, the test requirements that apply, and then the